Question 16. We are given information in a couple of triangles as shown in the diagram, and part A here is asking us to find the length of AD, which is this part here. Now that is part of the following triangle that I'm drawing here in blue. We are given two lengths inside this right angle triangle, length of 10 and a length of 15. So if I even just look at that separately, we've got this 10, we've got this 15, we're looking for an unknown side, which means we're going to be using Pythagoras to find the length of a smaller side. Call it A, call it B. That's probably the best way, given that the formula is as follows. So we sub in the information that's given. We have A squared plus 10 squared equals 15 squared, because C must be the hypotenuse. And then we are going to solve this equation for A. So first thing I could do is square the numbers that we have here to give us 100 and 225. Take away 100 from both sides, giving us this. And then I'm going to square root both sides, giving us A is 11.180, so on and so forth. Question wants to correct the three significant figures, so I'm going to be rounding after not the first, not the second, but the third significant figure here. That 8 is going to turn this 1 here into a 2, so 11.2 is our final answer. Part B, same triangle, calculate, or same picture diagram, sorry, calculate the size of angle BCD, so the angle at C between the lines B to C to D, like so. So it's the angle that's been marked here. We once again have a triangle that is right angled with this. We are given two pieces of information in the form of the 10 and the 12.5, but this time we're looking for an angle. So we're going to be using SOHCAHTOA, our trigonometric ratios. So we have this 10, this is definitely not to scale from my picture. We have 10, we have 12.5, and we have an unknown that I'm going to call x. Sides that we have involved in this right angle triangle here, we have the opposite side, and we do not have the hypotenuse, we do have the adjacent. If we have opposite and adjacent, we are going to be dealing with tan. So tan of the angle is opposite over adjacent. Our angle is x, so I can just leave that as is. Our two sides are, the opposite is 10 over the adjacent of 12.5. In order to get x on its own, I've got to inverse tan in order to make that tan disappear, or shift tan, arc tan, whatever you want to call it. So I'm going to do inverse tan of 10 over 12.5, and the calculator from that is going to give me, I'll write it over here, 38.659. We once again have some rounding to do, one decimal place, meaning that the rounding is going to happen here. And that 5 is going to turn that 6 into a 7. So 38.7 is our final answer. Done.